Hi everybody, welcome back to our statistics class notes. We're now on page 122 and we're working our way through a hypothesis test to determine if we have enough statistical evidence to show that American support for stricter gun control laws has increased from October of 2000, let's see, when was it? October 2017 to February of 2018, where in October 2017, we got about 68% of Americans supporting stricter gun control laws, and we did a sample in February of 2018, saw it was around 75%. So we want to know if that sample is enough to say we have statistical evidence to show that there has been an increase in Americans' opinions on stricter gun control laws. Okay, so we just went ahead and verified the essential limit theorem conditions. We set our hypotheses on the previous page right here. The null is that it's the same as it used to be. And our alternative that we want to see if we have enough evidence to demonstrate is likely true is that it's actually greater than that 68%. Okay, so P is greater than 0.68. Okay, so we often are given a significance level, which is the chance that we want to take of willing to being wrong, of rejecting the null and saying we do have enough evidence to support the alternative. Typically, a common one is alpha equals 0.05. So, and then when we find our test statistic, we'll compare it. We'll compare the p-value to that. The p-value is probably the test statistic being what it is or more extreme. So if we get a test statistic out in the right tail, we look at the area in the tail beyond that test statistic, and if it's less than this alpha, we'll have enough evidence to reject the null and support the alternative. Okay, so the values in October 2017 are what we're considering parameters. That's what we're considering true about the population. And the values in 2018 are where we get our statistics. So we need the test statistic, z. Remember, z hat is p hat, which is what we get from our sample, minus p naught, which we hypothesized in the null, divided by the standard error, where the standard error uses that null hypothesized value. So our p hat was about, like I said, 75%, about 0.7502. Our p naught was 0.68. So the numerator of z is p hat minus p naught, divided by the standard error, again, where we use p naught in there. So that came out to be 4.77. So that means our test statistic is 4.77 standard errors or standard deviations above what we hypothesized to be the null. So if that were really the population proportion 0.68, that would be a very unlikely test statistic, right, to get something that's 4.77 standard deviations above. Okay, so what I want to do is actually, I'll show you in the next sample here. And so the p-value, this is going to be really small, certainly less than 0.05. But let me go ahead and show you how all these calculations that we did by hand can also, of course, be done by StatCrunch. So I'll do that in the next video and show you how we get these numbers with StatCrunch.